Hi guys, we are back with a new video that is we are going to discuss the 2020 essay, and in the essay we are going to discuss the mechanics problem, right? So we have already covered the discussions of the MCQs of the mechanics units and dimension, and then waves and oscillations up to the light optics part. And I have prepared a video and then I have uploaded that. So if you have not already gone through it, so you can go through it. So this will be a short video based on how to answer the mechanics problem of 2020, right? So 2020 we were right. All right, so let's see. Fine. It says initially, right? Just simply, this is not that difficult, right? So this question, if you see, it says a uniform block of mass m, right? It's a block of mass m is placed, is initially at rest on a horizontal rough plane, right? Then a horizontal force P, which is gradually increased from zero, is applied on the block. Let frictional force be F, right? Frictional force be F. We need to draw a free body diagram. As the first problem, we need to draw a free body diagram of the block for the above situation and name all the forces, right? So this is pretty much a very basic problem, right? We will see how it's done, right? So they're saying we need to consider a like as the first problem, right? We need to consider a box, right? So a block actually, right? A block, and then that block, of course, there is a this thing we call it's placed on a rough horizontal surface, right? So we need to mark, and then they're saying like, what do they say? They're saying uh, a horizontal force capital P, which is gradually increased from zero. A horizontal force is being applied on this, right? A horizontal force capital P is acting on this, right? And then it's going to start from zero, right? So what might happen? So this is placed on a rough flow. So this is placed on a rough flow. Obviously, we know if it is placed on, it doesn't matter rough or smooth. When it is placed on another contact surface, like obviously there's a contact between these two surfaces, right? So these two surfaces are in contact. So in that case, it doesn't matter whether it's rough or smooth. Obviously, there's going to be a reactional force acting on the object in the upward direction, right? So there's going to be a reactional force acting on the object in the upward direction, that is R, right? So and then also along with that, the equal and opposite magnitude, equal and opposite force is acting on the flow, but ground, we are not going to consider that, right? So we do not have to worry about that. So next, the most important thing is, since this is a rough flow, like the object tends to move in which direction? So object is tried, like we are trying to move this object in the right direction, right? So if when we are trying to move this in the right direction, like when we are increasing this from zero, suddenly will it move? No, it's not going to move, because if we are increasing the force from zero, since this is a rough flow, there's going to be a frictional force acting in the opposite direction to which we are applying the force P, that is the frictional force, right? So F is what actually? It's the frictional force, right? And what is R? Reactional force, right? So yes. So now, yeah, that's done. So this is the free body diagram. This is going to be the free body diagram. So the important things to note are better not draw them, right? So as in contact, right? So you could have drawn it as this also, but let's not do that, right? So we could have drawn it as this, right? So then, of course, the issue is like we can't clearly show on which surface is this friction acting, and from which surface is this reaction is exerted, and also these things are quite like difficult to identify. So for that purpose, of course, we are not going to draw that as like we need to avoid the contact surfaces, right? Hope you understood the point in that, right? So now let us see But is the next problem, right? So they are saying sketch the graph of the frictional force, right? So F is frictional force against P from the initial position until the block moves with an acceleration, right? So we need to understand what they're asking is, it's a simple problem. That is, now usually if there is the block, right? If the block is there, and if you are applying a force like a capital P force, right? If you're applying capital P force, right? Simply a friction force is going to arise in this direction, right? So if you are increasing this from 0, 1 Newton, 2 Newton, 3 Newton, 4, likewise, if you're increasing this, accordingly, this frictional force will also increase 0, 1, 2, 3, likewise, right? So why? Because F is a, right? F is a self-adjustable force, right? It is a self-adjustable force, right? We know what is self-adjustable. Self-adjustable means, right? So when you when you do some external work, or else when you apply some force, the correspondingly this force, the frictional force, also changes. So what are the other types of self-adjustable forces? For example, now if you hang a box, right? So let's assume the tension is T. If you hang a 10 kg, so then this is going to be what? 100 newtons, right? So then if you when you hang around like 20 kg, right? 20 kg, what? Tension is going to be 200 newton, right? So this keeps on increasing, right? So like it's adjusting, right? But can you keep on increasing this until infinity? No, right? So there's going to be a maximum position, right? There's going to be a maximum limiting. We say that limiting. There's going to be a limiting tension, right? So where, like for example, let's assume if you hang 1,000 kilograms, this would break, right? So this is going to break if you apply hang 1,000 kilograms, which means the tension is the maximum limiting tension is 10,000 newtons, right? So simply each and every self-adjustable force is going to have its maximum value. For example, also like what? Like the reaction, right? So when you consider the reaction, right? So when you consider the reaction, even the reaction is a self-adjustable force. It depends on the mass, right? So if you if you apply another mass on this, right? For example, if you increase another mass on this, so the reaction, like for example, if that is mg, simple mg, now the reaction is going to be capital M plus simple mg. If you add another small mass, right? So things are going to increase, like it will keep on increase reaction force also, right? So even that is going to have a maximum value. Even if that surpasses, this is going to collapse, right? So similarly, friction is also going to have its maximum point, right? So it's like this. So if we draw the graph, right? So if we draw the graph is going to look like this. This is the x-axis, sorry, y-axis. This is the y-axis, right? So let's take the y-axis as. So what do they ask us to do actually? They are asking us to draw F against P, right? F against P, right? So what do we change? What we change is P, right? What we change is P. Simply what we change is P. So as a result, what changes is the frictional force, right? So it's like this. That's the particle, and we increase the P. So this P will become the what? The P is going to be the independent variable, while F is going to be the dependent variable, right? So you're going to keep on increasing this P. As a result, what happens is this F will also increase, right? So it's going to increase as this actually, right? So it's going to increase when P is 0, F is also 0, right? When P is 1 Newton, F is also 1 Newton, right? When P is 2 Newtons, F is also 2 Newton. Likewise, it will keep on increasing a self-adjustable force. It will try. It's going to be as this, right? which means this is going to be look like 45, right? 45 minutes. It's going to be as this, and then it's going to reach a maximum point, right? So there's going to be a certain force P where the frictional force is maximum. We call that frictional force as limiting frictional force, right? So if you increase the P beyond that, what will happen is this block will start to move, right? If you increase the P beyond this value, let's assume P naught, right? If you increase P beyond this P naught, then the block will start to move in the forward direction, right? So what happens is it's going to suddenly drop. The frictional force is suddenly going to slightly drop, and it will be constant throughout, right? It will be constant throughout. So this is called as the dynamic friction. This is called as the dynamic friction, right? So simply it's like this, right? So you keep on increasing the P force, frictional force will keep on increasing. So will the block move? No, because P is equal to F. At a maximum value, at a certain value for P, for example, P naught, right? For example, P naught, what happens is F will become its maximum frictional force. So at that point, what happens is the block will just start to move, right? Just start to move. So at what point? When P naught is equal to limiting FL. So when P is greater than FL, right? If you apply a force P, which is greater than FL, at that moment, of course, now suddenly on the block, what is going to arise is the dynamic frictional force, right? So dynamic frictional force, right? So now what arises is the dynamic frictional force. It doesn't change. It doesn't matter how much you change this P, this FD will not change. It will be constant, right? It doesn't matter how much you change the P force, FD will always be constant, right? It is going to be somewhat less than the limiting frictional force, right? The maximum frictional force, right? So this region we call that as, right, static region, right? So this region we call the static friction, right? At this region, it's the static friction. At this region, it is the dynamic friction, right? Why do we call them as that? Because in this region, the object is moving. It is in dynamic motion. So the friction acting at that moment is dynamic friction. At this region, right? At this region, the object is not moving. It is static. It is still. So therefore, the friction that acts, we are going to call that as static friction. Hope you understood that, right? We have discussed that now. So that is also done, right? So we have drawn this thing, and this is also done. We need to next discuss, write down expressions for coefficients of limiting frictions and dynamic friction. So this is quite easy. It's not that difficult, right? So we need to find, right? So we need to, we're going to find expressions for dynamic friction. Dynamic friction is mu d into r. Static friction is mu s into r. So what is mu d? Mu d is, they have given, right, coefficient of dynamic friction, right? What is mu s? This is coefficient of static friction, right? Okay, so this is how it's going to be. So what is r? R is simply the reactional force, right? Reactional force, right? Now let us move on to the next problem. That is also done, right? That's also done. Let us move on to the B part. So in the B part, they're saying in the front wheel, drive cars, right? So there are types of vehicles where some of the cars are driven by the front wheel and some of the cars are driven by the rear wheels, and also there are some vehicles where four wheels are being driven also, right? So four-wheel vehicles means the wheels where all the 4 vehicles are connected to the engines and they are operated by the engine, right? So front wheel vehicles means only the 2 of the front wheels are connected to the engine and they are being driven by the engine. So the rear wheel, it is just neutral. Like neutral means like it's not connected to the engine. It rotates as a result of the rotation of the front wheels, right? So it's like that, right? So usually bicycle and all, so that bicycle chain is connected to the back rear wheel. So the front wheel rotates as a result of the rotation of the back wheel. Hope you understood. That is what we call as front wheel. Front wheel means the rotation. In the front wheel, only the this thing, the front wheels are rotated by the engine, right? Okay. So the engine is coupled to the front wheels. They have mentioned that also, right? Through the axles. Consider a front wheel drive car moving in a horizontal, straight, rough, rough tar road as shown in the figure below. The coefficient of friction between tires and they have given the coefficient of friction as this and mu d as this. So what is mu L? Mu L is the static coefficient of friction. Mu d is the dynamic coefficient of friction. Consider only limiting and dynamic frictional forces acting on the car when solving the below unless otherwise stated, right? Okay. So as the first problem, what they are asking is the situation when car accelerates on horizontal rough road is shown in the diagram, right? So this is it. In this diagram, it shows a car accelerates on horizontal straight road, right? So copy the wheels A and B of the diagram in your answer sheet and mark the frictional force on. We have to mark the frictional force acting on the front wheel A and the frictional force acting on the back wheel B, right? So this is what we need to do, right? So simply, sorry about that. Right. So this is B part first question, right? B part first problem. Right. Okay. So in this, they have given a vehicle, right? Sorry. Right. And it's moving on a road, right? So it's moving on a road. So the thing is, now we need to mark the forces. This is the A, front wheel, right? This is the B, rear wheel, right? So now you need to understand the front wheel is the wheel that is rotating. This thing is given to the front wheel. So the engine is connected to the front wheel. So what happens is when you accelerate, you might have seen already, right? So the ground, the particles on the ground, all these things which is in contact with the uh, with the front wheel, it starts to, what happens? It starts to be thrown backwards, right? So for example, sand particles, all these things will be thrown backwards when it starts to move in the front direction, right? So therefore, in which direction will the friction act? So when this is rotating in this direction, right? Friction is going to act on the wheel in the forward direction. This is what you need to understand, FA, right? So it's like this, the wheel, right? The wheel is rotated in this direction. It's rotating in this direction. So as a result, the friction will act opposite, right? F A is going to act in this direction, right? So the friction on the ground is going to act in this direction, but that doesn't matter, right? So we do not have to draw this force FA and all, right? What we need to draw is only this FA, right? So the friction acting on the wheel. So hope you understood that, right? So that is for the wheel A. So if we consider the wheel B, right? So wheel B is a wheel that rotates as a result of the motion of the vehicle. The vehicle is moving in which direction? The vehicle that this for the tire B, right? So it's connected to the vehicle. Vehicle is moving in the forward direction, right? vehicle is moving in the forward direction. So therefore, the friction will act opposite to the motion, right? The friction will act opposite to the motion, FB, right? So this is how the frictions are going to act, right? So on the B, it's in the backward direction, right? On the rear wheel, the friction will act in the backward direction, right? Backward direction. And on the front wheel, the friction is acting in the forward direction. Due to this forward force acting on the vehicle only, the vehicle will get that driving force required to move forward, right? So obviously, to move forward, the vehicle requires a driving force in the forward direction, right? That driving force is acquired by this force which is acting on the wheel in the forward direction. Hope you understood that. The wheel is rotating in this direction by the engine. As a result, in the opposite direction, the frictional force will act, right? So that force will be the driving force. That force will be the force that supplies the forward driving force to the vehicle, right? Okay, fine. That question is also covered. All right. Okay. Then they are asking also compare the magnitudes of FA and FB when accelerating. Right. So when accelerating, right? When accelerating, actually, we need to know when accelerating. If the vehicle is accelerating, so what are the two forces acting on the what are the two forces acting on the sorry what are the two forces acting on the wheel now, right? That is a frictional force is acting in the backward direction, FA. Another friction, okay, this is acting in the, sorry, this is FA, this is FB. So actually, if the car is accelerating in the forward direction, right, then there should be a resultant, right? There should be a resultant force in the forward direction. The only two forces on this car are FA and FB. So what will be the resultant force? So since the resultant force is acting in the forward direction, right? Simply FA should be greater than FB, right? If A should be greater than FB, then only there'll be a resultant force. That resultant force is what? Resultant force is FA minus FB. You're not required to write these things, right? So just saying, right? Since you need a resultant force, right? So that resultant force is going to be given due to this higher FA force, FA minus FB. And so FA is going to be higher, the forward driving force, right? So that is right. So next we are going to move on to the third problem, right? So yeah, not the second, like we did not cover the second one yet, right? Right, we are going to see the second one now. In the second problem, they're saying, right, the mass of the car, including a driver, is 1,200. The total mass of the car, right? Right, the total mass of the car, which is equally distributed over all the four wheels. This mass or this weight is equally distributed over the four wheels, right? So identify the correct coefficient of friction. We need to identify the correct coefficient of friction in the situation. Like let's say when the calculate the maximum initial driving frictional force acting on the horizontal, right? We need to find what? Calculate the maximum initial driving force, right? It's like this. Now, simply in this problem, right? This is the second part, right? Simply that's the vehicle, right? Right? Sorry. In this vehicle, how many wheels are there? There are 4 wheels, right? So 4 wheels are there. So this total weight, what is it? 1,200 kilograms, which means 1200 Newton is acting on these 4 wheels. So what will be the weight on one wheel? What will be the weight on acting on one wheel? 12,000 divided by 4. It is going to be 3000 newtons, right? It's going to be 3000 newtons. So simply it's going to be 3000 Newton acting on one wheel, because like they have said, equally distributed over all the 4 wheels, right? Okay. And then they are asking, calculate the maximum initial driving force. Initial driving force, we need to find the initial driving force, right? Driving force is given due to whom actually? Due to F. FA is the guys who are, FA is the driving force actually, right? So let us find that. So first of all, let's find this FA. How do we find this FA? FA is mu R, right? R we know now, R is 3000. Why? Because if we consider a wheel on the wheel, a 3000 Newton weight is acting, right? So the reaction, so therefore the reaction acting on the wheel will be what? The reaction acting on the wheel is, it'll also be 3000 Newton, right? So we have found the reaction. So we need to find FA. When we find FA, right? FA, the frictional force, maximum frictional force is mu R, right? So now it is initially at rest. We need to just start motion. That is what we need to do, right? We need to just start motion. They're saying calculate the maximum initial force of the car. Initial force, initial driving force. The car is initially at rest. We need to just start motion. So when we need to just start motion, the friction that we are dealing with is what? The maximum coefficient of friction, right? We are dealing with maximum coefficient of friction. Maximum frictional force. We are dealing with maximum frictional force, right? So how do we find that maximum frictional force? Using limiting coefficient of limiting friction, right? By using coefficient of limiting friction, right? The reaction into the reaction, right? So yes, right. So FA is going to be what? Mu L is given to be as what actually? Mu L was given to be as, it was given to be as, if we see, where is it? 0.8. It was given to be as 0.8, right? 0.8 into what? Reaction is 3000. So FA is going to be what? FA is going to be 8 into 3 is 2400 Newton. 2400 Newton. So the frictional force, sorry, the driving force on one wheel is 2400. But how many wheels are there? 2 front wheels are there. 2 front wheels are there, right? So we need to understand that there are 2 front wheels. Since there's 2 front wheels, right? So the driving force is going to be 2 into 2400 Newton. What is it going to be? 4800 Newton, right? 4800 Newton, right? So the driving force acting on one, because like both these tires are connected to the engine, right? So the driving force acting on one tire is 2400, right? The driving force acting on one tire is 2400. So therefore the driving force acting on both the tires are going to be twice that, right? 4800 newtons, right? We need to discuss the third problem, third one, right? So we need to discuss the third problem. So it says, when a car is moving with a uniform velocity, this is important, right? So uniform velocity on a horizontal road, the total resistance against the motion is 520. So what they're saying is the resistance, the total resistance against the motion is 520. What we need to find is the power, right? We need to find the power at that velocity. What velocity? At 72 kilometers per hour, right? So note these points, right? So in this question, what is important is when the car is moving with a uniform velocity, where the total resistance acting on that particular motion is 520, we need to find the power. So it's like this, very simple, right? So even for this example, we will consider, and we will consider a car, right? So it will be easy. So let's consider a car, right? So it's like this. So the same car, for example, let's assume is now moving in a horizontal road, right? So like total resistant force against that motion is what? What is it? 520 Newton, right? So this is moving with a uniform velocity. That means what? Acceleration is zero. If it is moving with a uniform velocity, acceleration is zero. So then what should be the force applied on the vehicle by the engine? Like there should be a driving force acting in the forward direction, right? So there should be a driving force, the force given by the engine. What should it be? This F, right? So simply since this is uniform velocity motion, right? Uniform velocity motion, what happens? If we apply F equals ma in the forward direction, F minus 520 is equal to m into acceleration is 0, right? So which means the forward force, let's assume Fp, right? So Fp is going to be what? 520 Newton, right? So this will be the forward force acting, right? So, all right. So forward force acting, forward driving force acting by the engine, right? Okay. So, right. So this is not what they are asking us to find, right? What they are asking us to find is the power, right? What they are asking us to find is the power. We know that the power is equal to force into velocity, right? So we know that the power is equal to force into velocity. The power at which moment? The power when the velocity was what? The velocity is given to be as simply 72 kilometers per hour, right? Like we can't apply the velocity in kilometers per hour. So in that case, we will have to convert that, right? So when finding the power, it's simply 520 into, when we apply the velocity 72, we need to convert into meter per second, right? So how do we easily convert this into meter per second? 5/18, right? So if we do a small simplification, right? So I guess it's going to be something around 520 into 5, right? Into 72, right? So all these things divide by 18, right? Divide by 18. So if you do that, you're going to get 1040, right? So the power is going to be 10,400 watts. This will be the power, guys, right? So this is going to be the power. Right. So let us go for the next problem, right? So yeah, the fourth one, right? So that is done. So this was done. This was done. Now we need to see the fourth problem. So in this, they are saying the car climbs. Okay, it climbs a steep road. Okay, this is a steep road with an angle of inclination. What? 12%. Angle of inclination, 12%. Right. And the same horizontal power at where the same horizontal power is acting as in this, right? So what was the power? That was 10,400 or something, right? Watts. With that power, it's climbing up. If the total resistant motion is now 200 Newton, if the total resistance against the motion is now 200 Newton, then find the maximum velocity of climbing. We need to find the maximum velocity of the climbing, right? Okay, so simply they have given us the, yes. So fine, what were we doing, right? So yeah, let's move back to where we were the saying. This was the fourth problem, I guess, right? So yeah, the fourth problem. So in the fourth problem, the thing is, what we need to do is the vehicle is moving in a inclined plane. Obviously, this is 12, this thing 12 decrease, right? And let's assume this has the vehicle, right? So let's assume this has the vehicle. Now let's mark the forces. Now they have said the total resistive force is 200 Newton, and then also what is going to be mg sine 12 is going to act in this direction, and then what else? Reaction is going to be there, and then the weight mg cos 12 is going to act as this. You know how to resolve these things, right? So we are pretty aware of that, I guess, right? So if this is the object, this will be the mass, right? This will be the weight, right? So if we, according to geometry, this we would be getting to be as 12 degrees, right? So if we resolve it away from the angle, if we resolve it, it's going to be mg sine 12, right? And towards the angle, it's going to be mg cos 12, right? So I guess that's clear. So what they are asking is, now the you need to understand that the vehicle is having the same power. They have mentioned the power is the same, 10,000. What was it? 10,400 or something, right? Yeah, 10,400. Yeah, 10,400 watts. With the same power, they are this vehicle is moving in which direction? In the upward direction, right? Upward direction. What will be the force? FP. Now, yeah, simply let's apply in the upward direction. What? F equals ma, right? So if you do that, so what will be the force in the upward direction? Fp. What will be the forces in the like what the forces in the along the plane? The force acting on this vehicle along the plane is Fp. The force acting on the vehicle along the downwards the plane is what? Mg sine 12. Those are considered as minus mg sine 12 and minus 200, right? This is simply this is degrees, right? Not yeah, sorry, yeah. Anyways, fp yeah, so minus is equal to its mass. What is its mass? M. Its acceleration is what? So we need to see what the acceleration is. I guess it's not moving with an acceleration, right? So it's a while the car was again moving at a uniform velocity, right? So it's moving with a no. So what they're saying is the motion is same as before, right? So I mean, with the same horizontal power, you need to find the maximum velocity, right? Maximum velocity. You need to find the maximum velocity, right? Okay, which means the acceleration is going to be still 0, right? The acceleration is going to be still 0, right? Right. So FP is going to be what then? Mg, right? Mg is 1,200, 12,000, I guess, right? 12,000 into sine 12 is given as what? Sine 12 was given to be as, it was given as, yeah, sine 12 was 0.2, 0.2. Right, let's get back. Okay, so it's going to be 0.2 minus, sorry, plus 200, right? So FP is going to be, we will do the calculation, right? 12,000 into 0.2 plus 200. It's going to be 2,600, right? This is going to be 2,600 Newton. Now we can find the velocity. How? According to the equation from the power is equal to Fp into velocity. The power they have said it's same as the previous case. So 10,400 what we found it. Now in this case the force is 2,600 and to find the velocity, right? So simply if we divide 10,400 by 2,600, we're going to get the answer. If we divide 10,400 by 2,600, we're going to get it to be as 4 meters per second, right? So this will be the answer, right? So that problem is also done. All right. Okay, fine. Right, so let us move on to the final problem. That is, so the final one. Right. So this is done. Right. So we need to discuss the fifth question, part one. Right. So yeah, it's not yet done, right? So okay. So we'll see. So they're saying, they're simply saying, while the car was again moving at uniform velocity. Okay, this is important, right? So uniform velocity, 72, on the horizontal straight road. The driver suddenly saw an obstacle on the road at a distance 35 meters. So the driver has seen that obstacle in front of him at a distance of 35 meters. When he quickly applied the brakes, all four wheels were locked and the tires started to slip without rolling. So these things are given just to make you confused, right? So you do not have to worry about that. So then simply identify the correct coefficient of friction. All right, okay. And by giving a price, this is important. You have to identify the correct coefficient of friction, what to apply, right? So whether it's dynamic coefficient of friction that you need to worry about, or else the static coefficient of friction. Things could get bit messy if you can't figure out what to apply at which point, right? So you need to have a clear idea of what dynamic friction and static friction is. All right. So acting in this situation, and by this appropriate reasoning and calculation, state whether would the car hit the obstacle or not, right? So neglect the reaction time. Okay. So I will neglect the reaction time. Right. Fine. Simply, they're saying they have once again given the second problem of the fourth main one, right? So let us assume, okay, this is the car, right? This is the car, this is the horizontal road. Now, initially it was moving with what velocity? Velocity 72 kilometers per hour, right? It was moving with this velocity. Let's assume this point is point A. Now, just at this point, t equals 0, at this point, he saw an obstacle in front of him, an obstacle in front of him, right? Which is 35 meters in front, right? The obstacle is 35 meters in front. So now he applies the brake at this point A. When he is at the point A, he applies the brake. So just as he applies the brake, what happens? A frictional force is going to arise, right? A frictional force is going to arise simply when he applies the brake, the frictional forces are going to arise, right? Okay, in the backward direction. What is the frictional force that we need to find? What frictional force? It is the dynamic frictional force. You need to be very clear of that. You know why? Because still the object is moving forward, right? So it's not stopped. It has not come to rest yet. So in that case, what happens? Still what acts is the, like, since it's in motion, you need to consider this friction which is acting in the reverse direction as the dynamic friction, because it's not at rest yet, right? So hope you understood that point. All right, okay. So what are the other forces? Of course, the total reaction of the object, right? So mu d is there. So can't we find the friction? Now you need to understand there's no other forces acting on this, right? So will there be a this thing, what you call forward FP, I mean driving force? No, right? Because this already, because like just at this point A, right? At this point A, sorry, at this point A, right? The person completely, if he's not going to accelerate anymore, right? So he's going to completely release the system and then apply the brake, right? So he's not going to apply the acceleration and the brake, right? Both are not going to be done, right? It's not that lame, right? So I guess that's clear. So there's no forward driving forces involved, right? Okay, so can't we find FD? Yeah, it's pretty easy. FD is equal to mu D into R, right? Mu D into R. So what will be FD? FD is going to be, what is mu D? Mu D was given to be as 0.5 if I'm correct, right? So it was given to be as 0.5. R is 1200 because R means the mg, right? Mg 1200 into 10. So FD you will get something which is closer to, right? 0.5 into 1000, sorry, 12,000, right? It's going to be 6,000 newtons, right? 6,000 newtons acting in the reverse direction, right? Clear. Now, we need to find the deceleration. Now, this is going to go in a deceleration, right? So it's going to go in a deceleration, right? So we'll go in a deceleration because applying brakes means it's going to go in a deceleration. So we need to find that deceleration. How will we find that? So how will we find that? Simply to the motion, right? To this car, right? We need the only force that is acting is 6,000 newtons in the backwards. This is moving in the forward direction, right? Its mass is m. I will apply what? F equals ma in the forward direction, right? Simply, I can find the deceleration, right? So the force in the forward direction, what is the force in the forward direction? There's no forces in the forward direction. Only there is a force which is in the reverse direction, 6,000 Newton, right? Okay, 6,000 Newton. Mass is 1,000, 12,000, right? Acceleration, not 12,000 actually, it's what? It is 1,200, I guess, right? So what we get as the acceleration is minus 5 meter per square second, right? We have got minus 5 meters per square second. Now this is moving with what? Minus 5 meter per square second, right? Deceleration. Now can't we find now it's like this. It's like this. Simply let's assume at this point this was having an initial velocity of 72 kilometers per hour. It's moving with a deceleration of minus 5. Somehow it needs to come to rest, right? Shall we find the minimum distance required for it to come to rest? Shall we find this distance S? What is this S? The minimum distance required by the vehicle to come to rest due to this frictional force and all these things. Right. Let's do that. All right. So it's simply linear motion equations. What do we have to apply? We have uv, okay, v squared equals u squared plus 2a is in this direction. What is v? 0. What is u? 72 into 5 over 80. We need to convert that into what? We need to convert that into meters per second, right? Plus 2 into acceleration is minus 5 s. If we simplify this as s, we are going to get you may say s is going to be something around 40 meters. S was 40 meters. So now we need to decide whether it's going to collide or not. Now it's pretty obvious, right? So for him to come to rest, at least it needs 40 meters, right? It needs 40 meters. It's 40 meters, but it can't come to this point, right? There is a obstacle in front, so definitely it's going to collide. It's going to collide, right? So the answer is therefore the vehicle will collide, right? So this is the answer. Fine. Right. So let us go for the second problem, right? So this was done. Let us go for the second one, right? So in this, of course, they're saying if tires are slipping when brakes are applied, then the car will move a longer distance in a straight line without control, which can cause accidents, right? To avoid such slippings. So if it slips, of course, once again, it's going to be an issue, right? So if it starts slipping, even after we apply the brake, it's going to be an issue. So for that, of course, what they are doing is they are going to replace the brake systems with ABS, right? So ABS brake systems. And when tires, so here the process is when the tires starts to slip, what happens is ABS automatically releases the brakes and allows the tires to roll, right? This process happens several times, it it's like within a very few time interval, it starts it releases the brake, once again applies the brake, releases the brake, applies the brake. Likewise, it does this, and somehow it increases the effective coefficient of friction to a value of 0.5. It increases the effective coefficient of friction to 0.5. Like with this ABS brake system, you do not have to understand this, what happens in this ABS brake system and all. It's pretty lame. I mean, they have just asked you to repeat the same question that you did in the part 1 once again by replacing the mu as 0.75, right? So it's a very, I don't know, it's very simple, right? So you have to do the same thing and find at what distance, right? So you need to find at what distance at calculate the new stopping distance after the ABS system is fitted, right? So yes, now the only change is the coefficient of friction has become what? It has become simply 0.75, right? Let's go with that. Right. So let's see. It's the second problem of the fourth one, right? Simply now once again the same thing, right? The only change is that's like friction is going to act, right? Dynamic friction. The mu here is 0.75. Initially it was 0.5, right? Now it is 0.75 due to the this thing, ABS braking system, right? So shall we find FD? FD is going to be what? 0.75 into reaction. What is it? 1000, no, 12,000, right? So if D is going to be something around 9,000 Newton, right? So once again, since I have already explained this, right? So due to this frictional force, right? Frictional force of what? 9,000. I need to find with what acceleration it's moving forward, right? So I will apply F equals ma to this car, right? If I do that, what I'm going to get is because like since I'm applying the F equal ma equation in the forward direction and the friction is in the reverse direction, so it's going to be 9,000, mass is 1,200 into acceleration is going to be minus. So well, let's see, 9,000, right? 9,000 divided by 1,200, it's going to be something 7.5, right? 7.5 meter per square second, right? So now we will once again apply in this direction v squared equal u squared plus 2as and find the distance where it stops. If it stops, it should stop at like if final velocity should be 0, initial velocity should be 20 squared, right? So from where did this 20 come? So this 20 is when we can convert the 72 kilometers per hour into meter per second, we're going to get 20, right? So 20 squared and plus 2 into minus 10 into not minus 10, right? So in this time, of course, it's going to be 7.5 or something. Yeah, 7.5 into S is equal to 400 divided by 7.5 into 2 is what? 15, right? So 400 divided by 15 will yield you what? 26 point, right? It's going to be 26.66 meters, right? So this is 26.66 meters is less than 35 meters. Therefore, no collision will take place, right? No collision will take place, right? Okay, so that's done, right? Let's move on. Right. So finally, we have to discuss this problem, the sixth one, right? So here what they say is then he enters a horizontal or circular road of radius, of curvature, right? Of radius of curvature 18 meters, assuming that the coefficient of friction are same as part B, right? So part B means these friction, okay, 0.8 and 0.5. Find the maximum velocity that the car can move without slipping. It's like this, right? So simply what they are saying is, this is the sixth one, I guess, right? This was the sixth one, right? Okay, so here what it says is, it's like this. Simply, now there is a circular road, right? And in that there is a vehicle moving, right, as this, right? So this is uh, the front end, right, front end of the vehicle. So now assume, now if this needs to take this curve, taking the curve means this is the radius, right? So this should be the, this is the radius. So if it is taking this curve, then it's performing a circular motion, right? So hope you can you understand, if this takes this curve, circular curve, then that denotes this car is performing a circular motion. You know, if any object is supposed to perform a circular motion, then it should have a what? A force towards the center. What is that force called as? It is the centripetal force. It should have a centripetal force. It should have a centripetal force, right? Right. So the centripetal force is the force which balances the centrifugal as well. Like, forget about the centrifugal. Like if we talk about that, of course, it's going to get confused, right? So, so for someone who is further interested, this the centripetal force balances this centrifugal force, which tends to push the object away from the circle. Forget about that, right? So yes, simply, right, now what is the centripetal force? It should be in towards the center. So the center of the radius is here. Okay, the radius is, it was 18 meters. Now you need to understand who is going to supply this force. Who is going to supply this force required, centripetal force required towards the center? It's simply the frictional force, right? It's simply the frictional force, right? So this frictional force. Now what is this what frictional force? We have two frictional forces, the dynamic as well as the static. Now you need to understand the vehicle is moving in this direction. I can't show it through the mouse, right? So it's moving in this circle. Is there motion towards the center or else away from the center? Is it moving? No, it's balanced. It's balanced. It's not moving. It's not attracted towards or away, which means the force acting, the frictional force acting is the limiting friction, or the static limiting maximum frictional force. The frictional force that is acting is the maximum frictional force, because also we can get that idea because like the velocity is also max. You need to find the maximum velocity that is possible. So that if we need to find the maximum velocity possible, then we have to consider the limiting frictional force, FL, right? So we need to be very careful. So FL is what? 0.8 into mu r. R is 1,200, 12,000, sorry, okay. So FL is equal to, what is it going to be? 0.8 into 12,000. It's going to be 9,600, right? 9,600 newtons. So now next what I'm going to do is I'm going to apply F equals ma towards the center. Whenever you do a circular motion question, you need to if you come up with these kind of problems, you need to apply F equals ma towards the center. What is the force towards the center? The frictional force FL, right? What is the mass? That is to what is the mass? 1,200. What is the acceleration? We write. So what is the acceleration? The acceleration acting towards the center is the centripetal acceleration, or is the radial acceleration. How can we write that radial acceleration? Simply by using V squared over R. So what is FL? 9,600, 1,200 into V squared divide by what? 18, right? Divide by 18. So if you simplify, you are going to get a value which is closer to some. We are going to get a value of something around 12, right? 12 meters per second, right? You have to calculate that and see. So one a short summary about the question is, guys, this question looks very pathetic, right? I mean, like it looks very how do I say lengthy, right? But still it's given one complete page, right? So one complete page is going to be consistent of this problem, but still it's a very simple problem. You have to draw a free body diagram, sketch of the diagram. Like if you are quite uh, thorough or fluent in friction, right? So in friction lesson in mechanics, it's going to be pretty simple, right? And then you need to know how to apply power. Power is equal to P is equal to FV. So that equation. So this is a very pretty normal question, right? A normal question, although it looks like lengthy, right? You just do not have to worry about a lot of passage that is given, right? So what you need to worry about is only the questions asked, right? So okay, fine, I guess this is clear. Let's get back with another video. So if you think this was useful, so let us know in the comments. So in that case, we will try our best to post more videos. Just let us know in the comment section, right? So thank you guys, see you, and just let us know what kind of questions and then papers would you like us to do and post also, right? So, and then also make sure to share these things with your friends as well, and help a friend who might be at need. Okay, thank you guys, see you with some other video. Thank you and see you, right?